In this video, I'll be covering question 6, part D from the 2023 AP Calculus AB Free Response No Calculator Allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see the solutions to those other pieces, please check out my other videos. Okay, so looking at D right now, we've got a particle moving along the curve. At the instant when the particle is at this point right here, its horizontal position is increasing at a rate of dx dt units per second, and they want to know what is the value of dy dt, the rate of change of the particle at that same instant, so at that same point in time. What you can see here, you see these dt's on the bottom now all of a sudden, and what you've got to be saying to yourself is, I need to go find a dy dt. Well, to get that to pop, we're going to need to go back to that original function and take the derivative of that with respect to t. So you would come through here and you would say, okay, I've got 6xy equals 2 plus y cubed, and to get those dt pieces to pop, we're going to wrap this thing in a set of parentheses and we will ddt it. Whatever's on the bottom here, when you dd whatever it, you're going to end up getting these dx dt's and these dy dt things to pop. So you'll come through and we're going to be doing implicit differentiation here. Whenever I do implicit differentiation, I just have a little mantra. If you watch video 1, you already know it. That's every time I take a derivative, I get extra stuff. And what that extra stuff is going to look like is, consider there being a box behind that d up on top. And so whenever I take a derivative, I'll get the normal derivative, and plus I'm going to get d, and then I'll fill that box in with whatever the letter it is I took the derivative of over dt. So working our way through this, you'll remember if you watched video 1 part A here, then you would have seen that we've got multiplication going on here. So again, we still have multiplication happening, which means we're still going to need to apply our product rule. So the product rule recipe that I use goes fg prime plus gf prime. I'm going to label the first chunk the f piece, the second chunk the g piece, and then I break them out into their bite-sized little math problems. So f equals 6x, g is going to equal y. I now need to go find the g prime and the f prime, and it's when I'm doing this part of it that I'm taking a derivative and I'm going to get my extra stuff. So I take the derivative of 6x like I normally would, following the power rules. The derivative of 6x would be 6. I took the derivative of an x, so I get a dx dt. I go find g prime now. The derivative of y would have just been 1. Took the derivative of a y, so I get a dy dt. So again, that extra stuff, I'm filling that box in with whatever the letter it is I took the derivative of. Now that I have what I just call all of my ingredients, I'm just going to follow my product rule recipe to put this first piece together. So the rule says first go grab f. Cool. 6x. We're going to multiply that by g prime. Check. I don't really need the 1, so you can kind of leave that there. So then this would be dy dt. The rule says put a plus, go grab the g piece, which would be y, multiply that by the f prime, which would be 6 dx dt. So we're done with the left side of the equals, and we would keep going. Equals, and then working that derivative down. The derivative of a constant, no matter what method you're using, is always 0. And then the derivative of y cubed. Taking it like you normally would, you would get 3y squared. Took the derivative of a y, so we get a dy dt. Now, this is a little bit different than A. If you watched the video for A, we could solve this right now to get dy dt by itself and then plug in all of our values. But I will tell you, I personally like, when I've got numbers to work with as opposed to a whole bunch of variables, I prefer solving that algebra problem. So what you can do now is, you know, a dx dt value. That's 2/3. We know our point. That's our x and our y right there. So we can plug in for everything except what we're trying to find, which again is that dy dt. So then working my way through this equation left to right, I'll plug in what I know. So I've got 6. X from that point was 1/2. Dy dt is what we're looking for, so that'll stick around. Plus y from our point was -2. Then we've got that 6. dx dt was given to us as 2/3. That's going to equal 3. Again, we know what y is. Y is negative 2 squared. And again, we're trying to find dy dt. So again, I would much rather do this type of algebra with numbers in here than having all those letters and variables. You could do it the other way. You'll get to the same point. 6 times 1/2, let's just start cleaning this up. That would be 3 dy dt. And then we've got, so what can we start canceling? So a 6 and the 3 will cancel. That'll make that a 2 up top. So now I've got negative 2 times 2 times 2. That's going to be a negative 8 equals negative 2 squared is 4. 4 times 3 is 12 dy dt. And we're just doing normal algebra here. So I'm going to bring those dy dt's together. So because they're like terms, pull that 3 over to the other side, and we get negative 8 equals 12 minus 3 is 9 dy dt. And then our last move out of here was we would just go ahead and divide by 9, and we end up with dy dt equals negative 8 over 9. And that'll be our final answer for this, is negative 8 over 9 is what dy dt equals. Remember that if they gave you units on here, you want to make sure that your final answer has units. So you would say y dy dt is equal to negative 8 over 9 units per second, because they wanted to know the rate of change, and this rate of change has units with it. So that would be our final answer. We would have ended up with 2 points off of here. You'd have gotten 1 point out of this for doing your implicit differentiation part and getting that correct. And then you would have gotten 1 point for going through all that math and drawing out that final conclusion, remembering those units on that final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.